Hello, so today we're going to be looking at some simple ways to expand brackets. Brackets are these sort of curly containing things which people put like things like math inside them. And they're useful for when you want to uh, sort of factorize things, but they're useful for when you want to show that something must be done first. For instance, here on the left, I've got A open bracket, B plus C close bracket. Now these brackets, typically if these were actual numbers and not pronumerals, we would carry out the operation inside the brackets first. See, this is sometimes order of the operations. Sometimes there's different acronyms for it, like BIDMAS, or I think BODMAS is another, or there's lots of them, but essentially it would be brackets, orders, or so the I is indices, which is like your power. Then you got division, multiplication, addition, subtraction. I'll just write those as the order of operations. And so essentially brackets come first. As you can see, brackets come first. So we would do this first. However, here B and C are not like terms like we covered in the last video. So we just leave B plus C as that statement, B plus C. Now, if we want to expand this bracket, what we're going to do is this can be rewritten as A times open bracket B plus C. That's what's happening here, is there is a multiplication occurring. Now, we don't need to write that multiplication, so we just sort of keep it all next to each other, and it is side by side, and it's sort of implied. When you have A, there's nothing, no plus, it's just a open bracket. The bracket is meaning we're going to multiply by everything inside the bracket. To expand this now, what we do is we times our term by each term inside the bracket. So what that means is A times B is equal to AB. Next, notice we've got a plus symbol here in the middle, so I'm going to write that plus. Next, I'm going to do the next guy, A times C equals AC. That's the general idea of expanding brackets. So for an example with numbers, I'll write 2 here, open bracket, and then I'll write B plus 5. These guys are not like terms, so we can't do anything inside the bracket to simplify it. And if I do my multiplication here, I'll do the first one. 2 times B is 2B. Next guy, oh, I can't forget, I need to write this plus symbol here. So plus, and then 2 times 5 is 10. So that's how you would expand that. Now, if I was to give you something like 3 open bracket, which is like 3 times the open bracket, and then I'll write 2C plus minus C plus 3. What I can do here is notice inside the brackets I've got a like terms in that 2C and minus C are like terms. So I can evaluate this first. So I'll rewrite this as 3 open bracket, and I'm going to do this subtraction here, 2C minus C, and I get C. And then rewrite the other guy plus 3 because they're not like terms, so I can't do anything further. And then I'm going to do my multiplication on 3 times C plus 3 times 3, which equals 3C plus 9. Cool, that's the general idea. If you can evaluate something inside the bracket, then you can do so. And afterwards, you can carry out your multiplication on each term inside the bracket. Now, it is also worth mentioning, if I actually don't sort of take this subtraction and turn it into just C, I should still get the answer in the expanded form when I collect like terms, which is not necessarily easier, but it still shows that it all makes sense. So if I go my 3 times 2 I'll write it down here in red. 3 times 2c is 6c. Remember there's a minus here, so I'm going to write that minus. 3 times c, oh, see, this is where you need to be careful. And I think it works okay when you have just got pluses everywhere, but when we've got negatives, we need to be careful on how we multiply and how we look at each of those terms. When you multiply something by a negative number, you do consider that sign in front, right? So through positive 3 times minus c is negative 3c. So when you carry out this multiplication, it's probably best to actually consider the whole term is your multiplication. So 3 times negative c. And then the answer is at negative 3c. And I'm just going to write that there afterwards. So it's negative 3c. Lastly, 3 times 3, positive 3. So 3 times positive 3 is positive 9. So I can write that as well, positive 9. Now realize here 6c and negative 3c are like terms, so I can collect those and get 3c plus 9, which is the same as our other answer when we collected like terms first. Alright, so that's expanding brackets. I'm gonna say when you've got a plus symbol in the middle, everything's good. You can just rewrite that plus sign. But when you've got negatives and you're multiplying positives and negatives, you should consider that negative as with that term. So what I mean is when you multiply it with the negative in front. That is a key part of expanding brackets. And we're going to get into that and why that's more important in the next part. So here, when you've got a term in brackets and it is squared, like we've got here, it's in brackets and it's squared. A plus b all squared is how you would say that. I can rewrite this as a plus b times a plus b. Notice there's a times here in the middle, but I don't actually need to write it necessarily. See, there's a times here, but when you write terms side by side in brackets, the multiplication is assumed. So where do I go from here? These aren't like terms, a plus b times a plus b, so I can't collect any like terms. What I can do is multiply out the brackets, and essentially I'll show you that visually. What we do is we just connect each term, we multiply that, so the first term times the first term, then the next term, then the first term times the second term in the other pair, and then same with here, we're going to multiply this b times a and the b times b. What does that look like? Well, if I do it for you, I'll do this guy first. A times b, I write that as ab. Then I'll go this guy, a times a. I'll write that as a for now. But you can probably see it's going to be a squared, but for now it'll be a times a. And then b times a, I'll write that as plus ba. And then b times b, I can write that as b. Okay. Now I want to collect like terms. So I've got an AB and a BA. These guys are like terms. Even though they're not written in the same order, they are like terms. So I'll rewrite them here on the left, and then I'll rewrite my other guys. Now I can rearrange this to make it clearer. BA, I can rewrite that as AB. The order doesn't matter. Now AA, notice this guy has power 1 and the other one has power 1. Similar with B times B, it's power 1 times power with a power 1 as well. And now if I use my power rule, I can use it, say this is A1 plus 1 plus B 1 to the power of 1 plus 1. And if I collect my like terms of AB's, I get 2AB plus A squared plus B squared. The typical way someone would expand this in the quadratic, which is what is very common in sort of algebra, is A squared plus 2AB plus B squared. It's sort of the order that we like to use. We've got the like sum in the middle, the products on the ends. Now, if I was to do the next example, A minus B all squared, I'll show you how we rewrite this. It's A minus B all in brackets times another A minus B all in brackets. I'll do my first multiplication. I'll just write it as A squared now because that's A times A. Then I'll do my next multiplication. It's A times minus B, which is minus AB. Next up, I'm going to do my other guys. Minus B times A, which is minus BA. And then minus B times minus B, which is positive B squared. If I collect like terms, I get A squared minus 2AB plus B squared. So remember, you must consider this minus sign in front of the B or in front of your pronumeral as together with your pronumeral. It is a negative pronumeral essentially. Now lastly, difference of this form, A squared minus B squared, there's no brackets here. But I'm going to label this something because this is special. It's called difference of two squares. And this is very helpful to recognize that you've got a difference of two squares when you're trying to cancel out fractions with pronumerals. Why is that? Because difference of two squares, I can actually turn this into another form. I can factorize it into this. A plus B, all in brackets, times another set of brackets, A minus B. And I can show you that this is true because if I do my first multiplication, A times A is equal to A squared. Do my next multiplication, A times negative B is minus AB. Similarly, B times A is BA, or likewise AB. And B times negative B is minus B squared. See here in the middle, negative AB and positive AB are going to cancel each other out. So I'm left with A squared minus B squared, which is the same thing. The reason why this expansion is so important is because it makes, like I said, canceling fractions often very simple. Sometimes they will give it to you in this form and you can see the cancellation, or sometimes they'll be in the other form and you can see the cancellation. Either way, being able to go between the two is very helpful. Cool, that's been some general expanding brackets and a couple common forms when you're just starting out in quadratics, these guys, and hopefully that's been helpful. If you have any questions or suggestions or corrections, let me know. Otherwise, thank you. Bye.